Hello everyone. Thank you for registering for NVIS 101 Glass Solutions for Nighttime Operations. My name is Rick Miner. I will be the host during this webinar. It will be presented by Mr. Adam Wilsey, Manager of Research and Engineering for Kopp Glass.
Thank you, Rick. I'd like to start off with a brief outline of what we're going to go over in today's webinar. We'll start off with a brief history of Kopp Glass. We'll follow that up by some explanation on the night vision imaging systems. We'll then move into some current applications of those systems. And finally, some of the benefits and solutions that Kopp offers for those night vision systems. For those of you not familiar with Kopp Glass, we're a manufacturer of technical molded glassware. We were established in 1926, and our factory is located in Pittsburgh, Pennsylvania. We recently were ISO 9001 certified. Kopp Glass has a rich history of glass development. Kopp has developed many formulations over the years, including developing a selenium red glass in the 1890s. This red glass was used as a standard for the railroad industry for many years. In the early 1980s, Kopp acquired the Corning filter glass line, further expanding our vast catalog of colored filter glasses. Around the same time, Kopp developed what is known as our NVIS compatible glasses, and that will be the focus of today's talk. Kopp Glass originally developed the night vision filter glass line in the 1980s to work with and filter out the red and near infrared light in incandescent sources. We carry on this legacy with many of these same formulations used today to filter traditional incandescent sources. However, as a leader in the night vision filter industry, Kopp is continuously developing its filter glass line to work with other light sources, and recently, specifically, with LED light sources. Kopp is working to develop new, thinner, lighter weight glass night vision filters that will meet many challenges associated with LED usage in NVIS illumination applications. And now I'm going to discuss the science and technology behind night vision imaging systems. The human eye uses two types of cells for vision. The first type of cell are cones, which are used for daytime vision when there is a lot of illumination or light present. The cones are most sensitive around 555 nanometers, and this type of vision is called photopic vision. The other type of cells within the eye are rods, and they are used during dark or nighttime environments. The rods have a maximum sensitivity around 515 nanometers, and this type of vision is called scotopic vision. In night vision applications and environments, both types of cells are used. The cells within the eye also do not see all colors across the spectrum evenly. In fact, there are actually three types of cones that see color, and their sensitivities are shown on the left-hand side of the slide. The three types of cones roughly correspond to seeing red, green, and blue. This human eye response is just one important factor in determining color. The other important factors are the light source and the filter being used. It is a combination of these three elements, the light source, the filter, and the human eye, which determine color, and this is illustrated by the image on the right-hand side. Night vision goggles are different from human eyes, which are most sensitive from 510 to 560 nanometers. Night vision goggles have the greatest response and are most sensitive in the red and near infrared regions, specifically between the wavelengths of 600 and 900 nanometers. The Generation 3 night vision goggle tubes utilize gallium arsenide tubes, which are most sensitive in this region, corresponding to an increase in the starlight radiation as shown in the figure above with the arrow. It should be noted that these night vision goggles are not thermal imaging systems which operate in the longer infrared wavelength range. The electromagnetic spectrum is broken into several different regions of light. With night vision applications, we are most concerned with the visible region, which is outlined in the image with color, and the infrared region, but more specifically the near-infrared region from about 700 to 1,000 nanometers. The night vision goggles are most sensitive in the regions of the light spectrum just beyond what your eye can see. As previously mentioned, another important factor in color is the light source. Kopp has experience working with many different types of light sources, including incandescent, halogen, and LED to name a few. The images at the top of the slide show the light spectrum for an incandescent and white LED. As you can see, the incandescent source has a small amount of blue light and increases to have a large concentration of red and near-infrared light, while the white LED has a high concentration of blue light and lesser amounts of red and near-infrared light. Unlike incandescent sources, which will exhibit pretty consistent light spectrum manufacturer to manufacturer, white LEDs can come in many different flavors. The most important thing to consider when choosing an LED is color temperature. The easiest way for me to explain color temperature is how bluish or cool a white LED will look versus how warm or reddish that white color of that white LED will look. Examples of warm and cool LEDs are shown in the image versus some incandescent sources. The color temperature of white LEDs can be critical in trying to meet chromaticity requirements, and depending upon the color temperature, only certain filters may be able to be used to meet specifications. Night vision goggles are used by the pilot to view outside of the crew station or aircraft cockpit. The light from sources within the cockpit, as well as from external sources, can cause interference with the goggles. This excess light or illumination can cause what is known as blooming of the image within the goggle. Therefore, in order to gain maximum goggle performance, it is necessary to limit or suppress the light and energy from these external or internal light sources. Examples of images caused by blooming are shown in the image on the left side. With the issues experienced due to light source interference, there was a need to develop a standard for NVIS systems. This standard is MIL Standard 3009. The standard outlines 4 critical components of NVIS compatible systems. These components are NVIS radiance, photopic transmittance, contrast, and chromaticity. The need to identify and quantify color was solved by the 1931 CIE diagram and color space system. This color space system utilizes a fraction of red, green, and blue to define all the colors. The 1931 CIE diagram is the basis and color system used for many of the current color specifications, including for the FAA aviation specs and the indicator color specifications. In 1976, the CIE developed another color space system which took the 1931 CIE system and through some calculations made it easier to use. The 1976 CIE diagram represents color uniformity in the form of circles, which are easier to represent compared to the 1931 CIE diagram, which uses ellipses. The Military Standard 3009 uses the 1976 CIE diagram instead of the 1931 diagram due to the ability to represent the NVIS colors with circles. The Military Standard 3009 color circles are represented on the 1976 CIE diagram to the right. As you can see in the plot, the green color circles are to the left of the diagram, the white color circles are in the middle of the diagram, and the yellow and red circles are located along the top of the diagram towards the right. Although using the 1976 color diagram provides for the use of uniform color circles, it should be noted that within the military standard circles, the colors will appear different, and for this reason, Kopp has reduced the acceptable color range within the specification circle. If the color is not uniform, it can cause undesired distractions and color saturation, which can lead to eye fatigue. So it is beneficial for Kopp and the user to reduce the acceptable color range within each color specification. Another important aspect of the military standard is the NVIS radiance, which is a function of the light source, filter, and night vision goggle response. Choosing the light source, especially when using white LEDs, can be critical to ensuring the NVIS compatible system meets the NVIS radiance requirements. Cool white LEDs typically have less red and near-infrared light, which results in less NVIS radiance, while warm white LEDs have larger amounts of red and near-infrared light, which result in a greater NVIS radiance. Choosing an LED that pairs with a filter to balance both the NVIS radiance and chromaticity requirements can be a difficult and sometimes tedious process. It's best to take into account both the LED and the filter when developing these new designs and applications. Night vision technology requires compatible lighting both inside and outside of the crew station. Next, I want to look at some of the various solutions for NVG lighting compatibility. Current night vision filtering applications include avionic illumination, which involves NVIS compatible lighting applications in both fixed wing and rotary aircraft. Some of the lighting within the cockpit are listed. Other NVIS filtering applications include lighting for the outside of the aircraft, which can include lighting used for aircraft formation and navigation lighting. Kopp also manufactures a variety of infrared transmitting glasses which can be used to filter traditional light sources. These filters block the visible portion of the spectrum and transmit in the near-infrared region. These IR filters can be used to increase the visibility with night vision goggles. The filters also block visible light but transmit light that the night vision goggles use. These glasses see application on aircraft refueling apparatuses, airfield and heliport landing lights, some vehicle lighting, and IR flood lighting. These filters can be used in covert applications. Kopp's infrared transmitting glasses come with varying cutoff wavelengths, which you can see in the transmission versus wavelength plot on the left. Depending on the application, you can choose an IR transmitting glass that will tailor the amount of light that is emitted from your light source. For example, the 1283 glass will filter more infrared light, offering a 25% reduction in infrared light, while the Kopp 1290 glass will allow more infrared light to pass through, providing only a 45% reduction in this infrared emission. Kopp is continuing to work to improve IR glasses and to offer and tailor the light output in this IR region. Kopp also offers secure blue and green filter glasses. The secure filter glasses are commonly used to provide some visible light, which allows for illumination for the naked eye, but filters out some or even most of the light in the night vision goggle sensitivity region. These filters are typically used on military vehicles for illumination purposes. The use of night vision goggles is seeing an increase in usage in civilian applications. These NVIS systems are now commonly being used in medical evacuation vehicles, border patrol, police departments, and Coast Guard flight systems. And these are governed by the specification DO-275. Finally, I'll discuss some of the specific properties of Kopp's NVG compatible filters for interior and exterior applications. Kopp manufactures glass components for NVIS filter solutions. Glass offers several benefits, including enhanced mechanical strength, which helps to improve scratch and abrasion resistance. Kopp also offers NVIS filters with thicknesses as thin as 0.5 millimeter, which can help to limit the weight of the filter. The Kopp filters absorb the red and near-infrared light spectrum as an inherent property of the glass. This means that Kopp filters do not require coatings to absorb the infrared regions like some plastic or dichroic filters. The use of a single filter can also reduce expense and limit reflectivity compared to coatings that use reflection to filter the near-infrared region. Since Kopp NVIS filters use a single piece of glass to filter, we can produce filters that maintain high transmission at varying eye positions, as well as no color shifting between vision angles. This provides filters that are consistent in chromaticity and transmission properties. Glass is also an inherently stable material both to UV exposure, moisture, and humidity, which is another benefit of using filter glasses provided by Kopp Glass. More than ever, with the emergence of LED technology in the aerospace industry, the ability to tailor NVIS filters is critical. Kopp specializes in formulating our glass compositions to meet your requirements. Kopp can customize our filters to tailor the radiance to the application and help determine appropriate light sources to help meet your needs. Besides just custom formulation, Kopp also has the ability to customize the shape or format the glass comes in. Kopp has the ability to mold our night vision filter compositions, providing precision molded parts for a wide array of applications. Kopp does provide the filters in the common 6 by 6 inch by 6 inch square as well, which can be used to fabricate filters into desired shapes and thicknesses. Kopp's molded night vision filter glasses can provide for unique shapes and designs while limiting the costs associated with additional machining. Some current and common NVIS molded shapes include domes, cylinders, and some complex contours and curves as shown in the image above. Kopp's night vision molding capabilities are not limited to the typical NVIS glasses. Kopp also specializes in molding IR transmitting, visible absorbing glasses. These glasses have been used in a wide range of applications, including exterior aircraft lighting, IR flashlights, and ground lighting. These glasses find most of their use in covert illumination circumstances for these applications, and some examples of rondels are shown above. I wanted to conclude today's webinar with a brief summary. Kopp has an extensive line of glass filters that work with many various light sources. We specialize in customization. Glass offers many beneficial properties, including abrasion and scratch resistance, as well as humidity and UV stability that make it the ideal filter solution for mission-critical applications. And finally, Kopp's molding capabilities allow designers to utilize unique shapes or designs in developing new NVG-compatible lighting solutions. I would like to thank you for your time, and Rick, I'll hand it over to you.
Thank you, Adam. And to all of you in attendance, I hope the content of today's presentation was informative and relevant to your expectations. We will be sending out a post-webinar survey, so I will thank you in advance for your participation. That will be to gather feedback on this particular webinar, as well as gather ideas for future webinar topics that may interest you. For those of you who have submitted questions during the presentation, we will be responding to those questions via email over the next few days. I also want to mention that later this month, we will be releasing an interactive NVIS formulations catalog. So once more, I would like to thank you for attending, and this concludes today's presentation.